Well, ladies and gentlemen, what we're going to take a look at now, we're going to take a look at functions from number patterns. With number patterns, we have to remember that these all do have a rule. They have a function, and we're going to figure those out. The first thing that we want to take a look at is with our number pattern up here, we have a bunch of terms, and that actually responds, those are all correspond to our output. That's what you watched that video on before, where we know our output is a lot of times known as our function of x. In our numerator, what should be above that should be our input. So I bet you're wondering, if you know the output numbers, what is the input? The input's pretty simple. We just count these as the number term that it actually is. So if this is the first term that you see, this 18, that means that is term number 1. And then obviously that would make the 20 term number 2, the 22 is term number 3, and then the 24 is term number 4. So we always label them above. Now what I'm going to do is I'm going to actually find how my input, which is my x value, and my output, how are they each changing in this case? So first thing I need to look for is I need to look for from 18 to 20, how does that change? Well, obviously that adds 2. How am I changing from 20 to 22? Again, I'm adding 2. And from 22 to 24, again, adding 2. This is all about finding my rate of this pattern. We've looked at this through tables. It's essentially the same thing, just right now it's just worded a little bit differently, and a table is somewhat sideways, as we see. So now I got to figure out how my input is changing, and it's pretty simple again. We know that they are all changing by adding 1. So therefore, I know my rate in this problem is 2 for every 1. What that tells me then is my function is actually going to have a function of x. So f of x is equal to, I know if I'm adding 2 every single time, I know that this is a 2 times whatever my input value was. Now, we've done this several ways. What I need to look for right now is how can I figure out if this is the full function? Well, I have ways of testing that. I have all my input values up here. So realistically, what I have to look for is I want to know my function of at 1, what is its output? Well, I know I'm going to take 2 and I'm going to put it in and substitute it in for that x. Well, I know my function at 1, I know it's actually equal to 18, and 2 times 1 is only 2. So, as we've discussed, how do I get from 2 to 18? Well, you figured it out already. We're actually adding, so we're going up, and we're adding 16 to that. Now, I always tell my students to check. We're going to check that again. So now we're going to take it at the function of 2. And the function at 2, again, it's 2 times our input value there is another 2. And our function's output is 20. And 20 does not equal 2 times 2 is 4. That is not equal to 4. But how do I get from 4 to get to 20? Well, again, I'm adding 16. This is our constant. This is what actually ends up happening to the back of this function. So we are going to hypothesize that our function here is 2x plus 16. And let's make sure that is right. I am going to check. I'm going to go back here and check my work, and I'm going to take either 3 or 4. For this time, I'm going to use that coordinate right there, 424. So I'm going to check it and say our function at 4 should be 2 times 4 plus 16. Now our function's output at 4 was 24. Let's make sure that's right. So I know 2 times 4 is 8. And 8 plus 16 actually calculated and say that's 24. Is that equal to what I had originally, 24? It is. Therefore, our function is correct. So now I'm going to move on to another example. Here's our next example. In this case, more of the same. First thing I'm going to do is label my term number 1, 2, 3, and 4. And obviously all those top numbers are my x, my input, and then down below my f of x, my function of x, or my output are down below. So now I'm going to figure out how is my output changing. And obviously here I see it's changing by adding 10. And 10 for every what? Well, 10 for every 1 that I add up here for my input. Therefore, I know my rate is going to be a 10 over 1, which tells us our function has a 10 x in it, a 10 times x. And now let's figure out what else is on the back end here, because this could be it, but let's check. Let's check and see. First, I'm going to take this first one again. So when that function of 1, I have 10 times 1, and then my output at my function of 1 is 30, which therefore 10 times 1 is just obviously 10. How do I make it 30? Well, pretty simple. Again, I'm adding, and I'm adding 20. I go again. I go to test again. The function at 2 would be 10 times my input value there for x. I'm going to substitute in a 2. And we know from here our function at 2 was 40. That's equal to 20. But 40 does not equal 20, so therefore my question is, how do we get to that 20? Well, again, adding another 20. I see something constant. I see something consistent. Therefore, I think in here this is the function of x is 10x plus 20, and now I'm going to check it one more time. I can either use either 3 or 4. I'm going to use 3 right now, so I'm going to use this point. So I'm going to check that. The function at 3 would be 10 times 3, and then plus 20. I know my function's output at 3 was 50, and then 10 times 3 was 30, plus 20, and obviously 30 plus 20, 50. Does that equal 50? It does. Therefore, our function is accurate. So what you're going to do now, you're going to take a look at the problems that were given to you. You're going to work with these number patterns, and then you're also going to take a little review and work back with some of the tables as well as more number patterns for practice.